Hi boys and girls, welcome to science. Now this week in science we're learning about energy, different forms of energy. Energy is everywhere, it's a big part of our lives. And so we're going to start by introducing this topic with this book called Energy. Let's go ahead and read. Energy is everywhere. The car pulls into the snowy driveway. Shivering, you run into the house. You flip on the lights. Mom turns up the heat. You make hot cocoa. Energy made all of these things happen. Which things? The car pulling into the driveway, you running into the house, flipping on the lights, turning on the heat, and making hot cocoa. All these things need energy. Energy makes things work. It is everywhere. Do you see energy in this picture? Energy is making these cars go, these taxi cabs, also powering these big TV screens up here, advertising screens. Looks like here in Times Square, energy is lighting up the lights in the building. Energy is allowing people to walk back and forth on the sidewalk. Energy is everywhere. Energy cannot be created or destroyed. It moves from one object to another. Here's a picture of a boy playing pool. How does energy move from one object to another in this picture? Well, it looks like the boy has energy to push the pool cue, the stick, into the ball, the cue ball. And so the energy goes from him through the stick to the ball, and the ball goes forward. Energy is moving from this boy to this cue ball. So it moves from one object to another. On Earth, the sun is an important source of energy. It gives heat and light. This makes plants grow. People and animals eat plants. This gives them the energy they need to live. So energy is being transferred from plants and animals, from plants to people and animals. So energy is moving along. Types of energy. There are two main types of energy. Potential energy is stored energy. It has the energy it is the energy an object has that it is not using. So there's potential energy right up here when it's at this roller coaster is at the top of the hill. Okay, now when an object moves, it has kinetic energy. Kinetic energy. Now it's moving down, straight down. Wow, what a scary ride. But it has kinetic energy now. It's going down. So potential energy, it's stored energy, not being used at that time. And then kinetic energy is energy that is when an object is moving, energy is taking place. Potential energy comes in different forms. Chemical energy is one. Objects go through a change to use this energy. Food and gasoline are examples. So there's chemical energy there. Also food. Food is kind of stored energy. It's potential. Hasn't been eaten yet and turned into energy in your body. An object at any height has gravitational energy. This potential energy is used when the object falls to the ground. Look at this rock, barely balancing on this cliff. This is gravitational energy, and it's being stored right now. It's potential. It's not kinetic yet. But if and when it falls, it then has gravitational energy. It's moving down to the bottom of this canyon. Kinetic energy comes in different forms too. Motion is an example. As an object moves faster, its kinetic energy increases. So these kids are playing soccer and they have a lot of kinetic energy and it's increasing as they go faster. Heat is another form. It comes from molecules or atoms moving quickly. There's kinetic energy there. Potential energy can change to kinetic energy. For example, the potential energy stored in your food changes to kinetic energy when you eat it. When you have ice cream, it's potential energy there. And then when you eat it, it changes to kinetic energy because you get really hyper and you want to run around. You then use kinetic energy to move and think. It is the energy that keeps you alive. Wow, so look at this this picture here, and this, all the labels here. Kinetic energy, potential energy, kinetic energy. Wow. Energy in our lives. Most energy comes from non-renewable sources like oil and coal. There is a limited supply of these. Non-renewable means use at one time. Renewable sources are not limited. Examples include the sun, wind, and water. It's very smart. So these wind turbines are using renewable energy, which is wind. And there's always wind. Wind gets produced all the time. Geothermal energy is also renewable. This is heat energy inside the earth. Isn't that amazing? They get energy from inside the earth itself. People use non-renewable and renewable sources to make electric power. It powers lights, computers, and phones. People use it to store and cook food. Without electrical energy, life would look a lot different. All right, so thank you for reading this book with me. Here's a fun activity you can do to take a look at energy transfer, okay? We talked about potential and then kinetic energy. Potential is energy that's stored. Kinetic energy is energy that's causing something to move. So all you need for this experiment, excuse me, is a big ball and a small ball. So in this picture they have a soccer ball, which is a bigger ball, and then a small wiffle ball. So you can get a tennis ball, baseball, anything small like that, and then a bigger ball. Now you hold the big ball at the bottom, kind of make it look like a snowman with just two balls. And you hold the big ball there, hold the smaller ball on top, and then basically you let go both. Okay, they're both going to go down to the ground, right? But something's going to happen to the smaller ball. It's going to bounce, and as we see in this picture, shoot way off. Why is that? Why does the smaller ball shoot off and the bigger ball kind of stay closer to the ground after they both hit the ground? Where did the energy come from for that smaller ball to shoot off? Now go ahead and do that experiment if you'd like. And I think that, here's my theory, my hypothesis, is that I think the energy for the small ball to shoot off comes from the big ball, which gets bounced underneath the small one. What do you think? Is that a good hypothesis? Is that a good way to think about energy? I think so. Boys and girls, thank you for joining me today for science.